Hello, Maria.
Yes, hi, how are you?
We're doing fine. We're doing fine. Just whenever you're ready, just let me know in the chat.
Okay. And can you see my presentation?
How are you? Yo creo que es mi micrófono de... Yes, she hears us, but I think she's hearing my microphone from my computer.
Okay. Hello, Maria. This is Areti. How are you?
Hi, how are you?
Good.
And can you see my presentation?
Yes, we can.
Okay. I'm ready.
Okay. So it's very nice. We've met Maria Ayalova over the last few months, so we knew her work, guys. Though we knew the work of Terreform 1, we've gotten to know Maria Ayalova, one of the co-founders of Terreform 1 over the last couple of months as we've been developing the Global Summer School. Terreform 1 is design, let's say, I don't know, think tank, because not only do they design projects, but they also run workshops. They run a school called One Lab, which is actually ongoing at the moment. It started the 1st of July, and we're lucky enough to be part of it for 2 weeks. So I think a lot of the projects that they're working on are looking at how to make cities maybe more intelligent, and I think this really goes along with our agenda, and I think it's interesting to have them as partners, as we're in, let's say, we're synchronized on many of the ways that we think. So actually, Maria, we have some questions here prepared, but we'd love to see the work and introduce the participants here to what you guys do over there. So I'll hand it over to you.
Okay. Well, thank you for the introduction. So Terreform 1 is a nonprofit research and education group, and our focus is on the ecological future of cities. And in order to assure that this happens, we decided to start a new profession. So urbaneers are these new urban advocates, and their job will be to regenerate, pioneer, and sustain the future of urban Rome. And in order to do that, they have to combine previously disparate occupations. And you can see here you have a team of all these different professionals. And instead of putting together a Ferrari, they're fixing Manhattan and assuring its ecological future. And then we are always asked as an example with, an urbaneer. And here in this chart, we imagine if Jane Jacobs and Robert Moses were to be married. Very unlikely, because these two were arch enemies in their lifetime. However, if they were married and produced a child, that child will be somebody like Frederick Law Olmsted, combining the sensitivity and the social responsibility of Jane Jacobs together with the vision and magnitude of achievement of Robert Moses. And this is a very complicated chart of the different fields that each urbaneer can combine, but almost any combination will occur, will be good as long as it satisfies the challenges that we face in the future urbanization. And in order to teach this discipline of urbaneering, we started a school called One Lab. We've been running it for 5 years, and it's a experimental program that combines design and science in a single curriculum. We're in the middle of the 2013 session. Just very quickly, I wanted to show you some of the workshops from last year. I haven't been able to process the photographs from this year yet. But here you see this is a workshop on synthetic biology taught by Dr. Oliver Medvedik, where students are learning the basic principles and how that can be incorporated in both design of materials and systems. Here, Dr. Carlos Barrios is teaching parametric design using physical objects, and that was very interesting, a workshop where the students were able to achieve. Here, two students are vacuum forming these ceiling panels where they were actually growing mycelium, the root structure of mushrooms, into building blocks. And here, we are shaping living trees, stitching them together to create a structural wall made out of trees in a whole house, and I'll talk about it. And here, Walter Meyer is teaching the principle of phytoremediation, or using plants to remove pollutants both from the soil and from water. And here, the students designed and built this unit that is used to run black water through it. And now this year, once the plants were fully established and their root structure was established for a whole year, we were able actually to do tests with the 2013 students and to prove that this wetland species, in fact, can remove pollutants from black water. And so, where we are with one lab, we are starting next year 3 programs in Europe, including one in Barcelona in collaboration with IAAC, and Berlin and Prague. So these are full semester programs, and from there we plan to open programs around the world. And I wanted to tell you a little bit about our home here at the Navy Yard called New Lab, where we moved recently 4 months ago. So the Navy Yard is a large industrial park right in the middle of New York, here in East River, between Manhattan Bridge and Williamsburg Bridge. And here's kind of an area view. This is a place where they used to build big ships from the Revolutionary War onto the end of the Korean War. So the USS Missouri was built here, USS Austin, and all other large ships. And we decided to take on this former manufacturing building and convert it to a collaborative design and fabrication space. Here, when they used to construct engines, we are going to have now both students and professionals working side by side to this huge space. It's, I know we work in feet here, but it's 86,000 square feet with 80 feet ceiling. So the idea is to have several universities join us. Columbia University runs Little Polytech. We have programs here together with Terreform 1, of course, and One Lab and our collective that we started, and many other companies, small and large, sharing equipment, sharing resources, but also sharing ideas. Because innovation doesn't happen in isolation, and then you need that constant stimulation, but also ability to collaborate with other people, and that's kind of the very essence of educating this new urban year. So this is currently under construction and is scheduled to open by the end of 2014. We also have a very large event space where we'll hold conferences and talks, and also open it to the surrounding community and the global community. This project is a public-private partnership. This is Christine Quinn, who is the speaker of the City Council, and hopefully our future mayor. We have elections in 2 months here in New York, so we're hoping that she will lead the city following the footsteps of Bloomberg, but also work with us to bring this project to completion. And here, we're sitting today, it's what we call New Lab Beta. So we're in a building next door. We decided not to wait, but to start the community already from the ground up. These are the 2 developers who started the project. Behind them is a EOS 3D printing machine we are receiving these machines as a donation from a lot of companies who want us to push the limits and see what are the new applications possible for this technology. Just quickly, I'll show you some of the new lab members. Ecosystems, they're industrial designers. Here they invented this system called Snugget that you can furnish a whole apartment with it, so assembled by hand. Uses reclaimed wood in this case, and you can make all kinds of shelving, a table, a chair, a bed, and when you're sick and tired of it, you can change it on a dime. Jessica Banks is a roboticist that designs and builds kinetic furniture. This chandelier is a robotic chandelier. It's triggered by ambient sound, and so it can expand and contract and then throw light to different places in the room where people move around. Jacobs, he builds motorcycles, and he also designed these solar collectors for a new park being built here in New York City underground. It's called the Low Line, a reminiscent of the High Line. So the idea is that you collect light everywhere and send it down underground using optical cables and support photosynthesis underground to create this park. And this is a picture of it. Marcel Botter, he trains as an architect at the MIT Media Lab, a serial entrepreneur. Among other things, he just invented a new baby spoon called Spoonie, and he's launching it next week. Jenna Spivak is an artist who is working with microfarms, and her idea is that you can convert any piece of furniture in your living room into a microfarm where you can grow several plates of salads per day. This is my partner Mitchell Joachim and I building a big model of a future city. And then this is Oliver Medvedik, who is a partner of Terreform One, but also co-founder of GenSpace. I talked about him. He teaches synthetic biology, and he built a 3D bioprinter that can now print living cells. One of the ideas is to grow a living watch, and here it's kind of the first model of it, and this is using 3D cells. And then I wanted to show kind of some of the ideas that we have developed from going all the way from soft cars and using soybeans for the car shell to developing into the actual whole body of the car. This is a project that was started at the Smart City Group at MIT Media Lab, where my partner Mitch Joachim received his PhD. And we continue the work here at Terreform One. The idea of the soft car was that the whole car, all the transmission, the engine is in a wheel, so the body is preserved just for safety and comfort. And our idea was that nobody dies again in a car accident. So we, this is some of the bodies of the cars that are made, have these air coils that can be also deflated. These cars are designed for the city. They don't move very fast. They're similar size to smart cars, but they can fold. Some of them are already being built actually in Spain. But these are our designs, again, focused on just the shell of the car. Here, this car is not doing jumping jacks, but it shows that the wheels can move, so the car can spin and park easily, but also move up in a Z-axis and then be stored along the facades of the building. And here is where everything changes, because this is not just a vehicle anymore, but it becomes a battery on a wheel. So these electric cars, they can be connected to the grid. They can store excess energy produced by renewable sources and use it to satisfy peak demand. I don't know what is the weather like in Barcelona, but we are experiencing a heat wave here in New York City. So all the air conditioning is working and power becomes very expensive. They also can fold and lock into each other. so they can be charged at the stations. This is using the idea of a shared vehicle. So you're part of have a membership, and you can just pick a car. And then here are some other ideas about mobility. This is what we call the river gyms. These are powered by the Siemens buttocks, and you can exercise and move to cross the river at the same time. And finally, going in here, this is the idea of a blimp pass, where we're using these dirigibles connected to lift chairs that you can hop on and off and also move on water. And finally, the idea of the jetpack. The jetpack has been invented. You can purchase one for about $100,000 currently from Jetpack International. Our idea, again, has to do with safety, creating this inflatable bubble around it, so you can bump into buildings or into another people on jetpack. And here shows the section where there is also a parachute in your crotch just in case something goes wrong. So going further on, some of the projects that followed the idea of urbaneering produced by our students from One Lab. This is the idea of urbaneering Brooklyn, looking at several areas of Brooklyn, including downtown Brooklyn, projecting 100 years from now, always starting with research of the situation today, and see what we can achieve in the future under the premise that cities can become completely self-sufficient within their political boundaries. What I mean by that is that they have the ability to produce all food, water, energy that the citizens need, deal with all the waste. The only thing that will go in and out is culture. And by doing that, we did a study and the need of what we call productive green space. When Brooklyn was first established in 1776, they had a lot of it. They were able to filter water in the wetlands, have farms and pastures. Where we are today, we have zero productive green space. Here are a few parks, but they are partly used for recreation. Some of them even have fences around them, and basically no production. Where we want to be 100 years from now, basically redirect that trend and go back to where we originally started, but use new technology to do that. So this is also addressing the rising sea levels and storm surges that we experienced last fall, and opening up what you see kind of in a light color is the wetlands that can receive the surges and absorb them, and then the rest of it is used for production both of food and energy. And to achieve this here, this is a diagram to explain this reversing of the figure ground, removing all the dilapidated buildings that are not going to withstand the 100-year test, and replacing them by these very dense arteries that combine both housing, commerce, entertainment, and soft mobility, incorporated in a single artery, opening the rest of the block for productive space. And here, this is the ground level of the new downtown Brooklyn. We have removed the big QE, it's the big elevated highway that was built by Robert Moses and divided the city. And we have, instead of a canal on ground level, support both transport, but also creating, a flood infrastructure, and then opening up the space above. And here is a model of this future city of Brooklyn, where now the infrastructure comes in the foreground and becomes the new organizing principle of the city. And what you see in the middle is a huge water tower and research station So that becomes the new city center together with housing all the function of the government. So we shift from having a cathedral in a city center to having a central business district, and now celebrating an infrastructure as a new principle of these cities of the future. There are some more images from the model, and this is the type of productive green space that I'm talking about that combines both recreation, bike paths together with these are robotic algae farms that produce new fuel for energy. And here it's combining all these new types of mobility into what I call soft mobility. It's a new type of street where everything, including the streets, has a modicum of intelligence that it can communicate with each other. So always given a priority to people on foot and people on bicycles. And if something happens, and let's say there is a small girl playing with a ball and she drops the ball on the street can reorganize itself, stop traffic. So again, nobody gets hurt, nobody ever dies in a car accident. And then to achieve this kind of new ground, we had to create a soft edge around the city of Brooklyn. This is the current research where we look at how can we do that using this technique of Gaussian walls. We discovered that we can use old military ships as a construction material. Shipwrecking is a big industry, very dirty industry actually. We sell our ships as far as India and China. Military ships, however, cannot leave the United States. So we have thousands of them sitting around. We decided to create this new soft edge around the city, to cut them in sections and submerge them. We decided one specific area around Brooklyn where they can use simple sedimentation techniques to build new ground. And here is giving you kind of an idea of this process. These are, again, large ship sections that merge into ground. And they're starting to create this kind of a new soft edge of this new landscape. And finally, once it's fully established, 100 years from now, it's part of the new city edge. I'll show you a few other projects going all the way back to the PAP tree hub. This is the idea of bleaching living trees together to create a structural system. These are some historical examples of how this was done in the past. And our contribution is to use this parametric design, CNC manufacturer, reusable scaffolding to guide the plants to grow in complex curves. And this is some of the experiments that we've done here on the roof of our former building in downtown Brooklyn. This was grown in one summer using willows. And this is the whole design of a whole habitat now out of living trees. And you can pre-grow a whole village. It takes time in different climates. You can grow a house in a tropical climate in 3 to 4 years. Here in New York, it will take anywhere from 7 to 10 years. But the idea is that this is not the kind of the zero house. It is a positive contribution to the ecology, where it can serve as a place for humans and place for birds and other habitats. And this is a model of it. It's actually currently traveling. It's in exhibit in Paris, and it's going to go to Rotterdam after that. And this is how it can possibly happen. So this is the whole process. We're currently experimenting with pre-grown trees to cut the time shorter. And actually this fall there will be, at the Biennale in Rotterdam, there will be a gateway that we're going to construct together with the organizers. Moving from the PAP tree hub, this is what we call the in vitro meat habitat, or the media has labeled it as the meat house. And then we decided to build a biolaboratory in our office. We are probably the first design firm to do that. And the idea is to experiment with living matter using cells. And this technology, as I said, was developed. I show you a printer that you can use. You have a printer now to use living cells. This has been used in regenerative medicine for decades. You can regrow organs today. But our idea was, can we have a whole house made out of in vitro meat using this shape grammar and then assembling a whole house. Here is a comparison of a section of the wall, comparing typical stud construction used here in the U.S. versus the meat tectonic. And we imagine like bones can be used for structure, fat and skin for insulation, and the sphincter muscle, in this case, it's used as a window. And this is some of the renderings that we've done. Imagine it's not going to look pretty. It's a model. It's not alive. It doesn't have an immune system. So once we grow the meat, we actually have to kill it in the end and preserve it in order to use it as construction material. That's another image of it. And here we had a show in Prague when we first worked in this project. So we made a model and put it in front of the Prague Cathedral, so the meat house can confront religion. And as I said, we know that we probably are not going to grow a whole house out of in vitro meat, but there are other applications, and what we're currently working with Dr. Oliver Medvedik is to see if we can grow a whole, wristwatch using this technology. Rapid refuse is an ongoing research project, seeing how we can utilize waste as resource. Here is a quick study of the amount of waste produced by New York City. Today, we make 36,000 tons per day. You wonder how much that is? Here is how much we make in 1 hour in New York City. It's piled around the Statue of Liberty for scale. Here is a model of it, so you can get an idea. This is compacted waste. So we wanted to see what we can do with it, because basically in New York, we don't have a place to put it. We ship it to other states, we sell it to them, and goes to Ohio and North Carolina. So using off-the-shelf units, these are simple garbage compactors. We modified their jaws so they can produce this new building blocks in a puzzle-shaped fitting geometry, separating plastic from metal, from organic waste, and having this new system where the production of the construction material is incorporated into the construction of the building. So here is what we call the 24-hour tower. Using this technology, you can build a 54-story tower every 24 hours just using the waste produced by New York City. And the idea is that in the future, we'll move to what we call a positive waste. So nothing will be thrown away anymore, and everything will go back into all the different systems of production. Here are some examples. We've been doing a lot of activist work using, this is a gigantic snowflake made from styrofoam waste or e-waste. And here, this is Paul Miller, also known as DJ Spooky, at a concert at the Metropolitan Museum of Art in New York City, where we designed the whole stage. And this is just using 30 seconds of waste from this neighborhood only to demonstrate, kind of the potential of using it for something else and creating, in this case, an installation. And then here's a close-up of this star. And then we've been doing this as I said, an activist project here in Darmstadt in Germany. Same idea, working with students, building these robots, just collecting the waste produced by the city to demonstrate that you can use them actually to make art. This was the star that was also part of the Festival for Ideas for the New City of New York, organized by the New Museum every year. Behind it is the Big Bubble by Ram Labor. And finally, you can build a whole city using this technology of waste. I talked briefly that the students were experimenting with growing mycelium. This is this project and methods that we've developed that you can utilize the organic waste and make a type of a new brick that combines the outer shell of compacted aluminum, and the inside it's using the organic waste as a substrate to grow mycelium, which is just a kind of a biopolymer that can be grown from the root structure of mushrooms. A simple technology using aluminum refuse and a simple hydraulic press to press the outer shell and then the mycelium from the inner shell. We'll be developing this for countries in the developing world where construction materials are expensive and scarce. We have a plan where you can start a small shop in Brazil with a microloan for about $500 and start manufacturing these bricks. And this is the whole process of mycelium propagation. You start with the spores of these medicinal mushrooms that we are using, reishi. They're Chinese mushrooms that are used for tea. Substrate can be any type of organic matter, cellulose-based organic matter. You can use agricultural byproduct, cotton husk, buckwheat husk, which we experiment with. You inoculate it with the spores of the mushrooms, and within 8 days only, you have this dense biopolymer that has very good properties in terms of R value, soundproofing, water resistant, and can be used in construction. And it is a material, biological material grown from microorganisms and can be returned at the end of this cycle back to Earth, where it can feed other microorganisms. And here is a microscope image to show you this kind of a branching structure of mycelia. And our most recent work is focused now on combining this technology with another technology of growing bacteria in an analogous leather material to create what we call the Gen 2 seed. Here again in our laboratory, we have a team of students and researchers in growing mycelium and then growing Acetobacter, which is a naturally occurring bacteria. It's used in one of the health drinks sold here in the U.S. called kombucha. And the idea was to grow a whole baby seed out of microorganisms. And here is this kind of the idea of using Acetobacters. It is grown in thin sheets, and then you can shape it by draping it. And currently, we are doing experiments of cross-linking this material with chitin, which is the material that your fingernails are made of. And once you do that, this material becomes waterproof and can be used both as a leather material, but also incorporated in construction of buildings. And then we've gone through several different designs. It's kind of the idea that it is, because it's a seed, it was inspired by your tailbone. And this is the shape. It's used based on this segment because there is a limitation of how thick you can grow this material. And this is, as I said, currently also a traveling piece within Prague and currently in Paris in exhibit. And this is little Mia Joachim, that's my business partner's daughter. And then the hope is that once she grows up, we'll live in a world where we'll have these materials that are completely biological and biodegradable, as I said, grown from naturally occurring microorganisms that at the end of their life cycle can go back to Earth. Well, thank you for listening. That's all I have for you today, and I'll be happy to answer questions.
Wow. Is the first thing that comes to mind. Some really fascinating materials and fascinating processes. And it's funny, actually, I'm glad eventually that you had your conference right after we had Paco's conference, because there was a lot of discussion. Paco's a chef, and there was a lot of discussion, of course, about can our cities be, can our cities actually be self-sufficient in terms of food production for all of the citizens? There was some pessimism, some optimism, obviously, but his response was not so much about, seeing how we can transform the city, but more, well, if we're still having the tons and tons of food waste that we have every day, then maybe we should have that discussion when we change the mindset of all of us in the city. As long as we're wasting food, we shouldn't have the discussion of how we can transform the city to create new opportunities for food. But that was just a small point there. Do you guys have any questions about what we've seen from Maria? Any comments? What's this, Maria?
I think there are also new topics background to find out more, maybe in our project.
So you're digesting this,
yes,
this material.
I might have to do
I'm sorry, I couldn't hear very well.
It'll be hard for you to hear because they're out in the audience. No, Mattia was just mentioning that there's a lot of new materials and processes that are new to him. So he's kind of his comment was more he's now attempting to sort of digest and process the kind of work that you do. But he also mentioned that possibly it's an opportunity to maybe try to conceive of some of these things working on in the projects that they're conceiving at the moment.
Okay.
Yes, Areti has a question.
Hi, Maria, for the conference. So it's great to see you.
You're going to have to speak to the...
Yeah, can you hear me? Yeah? You hear me, Maria? Maria?
Yes.
You can speak to the computer.
You can read the question for me?
You're going to have to speak to the computer.
Okay, now I'm in front of the computer, so you should hear me.
Yeah, now it's good. Thank you.
Okay. Now, first of all, thank you for your conference. It's always great and inspiring to see your work. You are touching so many different scales, so many different disciplines and topics, from biology and construction and agriculture and transformation and social incubation. So I think it's great. I'm very interested with the work that you're doing in relation with the biocomposites. So I would like, I don't know if it is a question or just an observation, but, or an opening for a discussion here with the students. But I think it's interesting that when we start to think about self-sufficient architecture, we don't just think of plugging into the existing rigid architecture systems that, for example, they generate energy or they recycle some kind of resources, but rather your work is really pointing out the focus of getting into the nanoscale of the materiality of the buildings, of rethinking how we can start building architecture not with the traditional materials, not with the traditional techniques, but rather really growing cells on the beams of the buildings, and from the sections of the project that you saw of, I don't remember the name, but the one that you were growing biomaterial, bio-living organisms into the building. So do you see that this is maybe a new technique for the future so that we can do architecture out of scratch, or is it a technique that we can use to reform existing buildings and apply like an extra layer of skin that could adapt to environment or that could adapt to user needs? And how can you consider that we could use this kind of knowledge coming out from biology and combine it with the architectural techniques in construction or in thinking, no, in the thinking processes, in order to be, of course, productive on one side, but also self-sufficient, no, on the other side.
Well, it is our belief that in the future, we'll have to address material scarcity. We cannot continue, to build both buildings and cities using the old techniques, because we simply don't have enough materials. I mean, if China is going to house 250 million people in the next 2 decades, that is going to quickly consume all the world's resources. And the idea that, we have technologies that are either developed or under development today, that we can produce these new type of materials that are changing basically the whole paradigm of manufacturing. So you're not moving from extraction of raw materials from the earth using very energy intensive and chemically intensive methods to then transporting them across the world and factory producing construction materials, and again transporting them to the construction site to assemble them into a building. So this is using this principle of synthetic biology, that materials can be grown from microorganisms. And then that will require a paradigm shift. Again, these materials are not living in the end. They're just using the life sciences to produce them, but they are, end up as inert materials that can pass the current requirements of construction materials. So I think we can already see that some of them are slowly being incorporated in the process, and in the future we'll see more and more of it. Again, we'll have to, it's an uphill battle with, both requiring a mind shift, but also kind of how we shift the economy, because it still makes economic sense to, use a lot of oil or extract metals from the earth. So I think the science is there, or will be there soon, but it will require a collective will and a paradigm shift in order to see it happening.
Okay. Yeah, thank you. Any other questions? Okay, there is a question from Tehran. Okay. From Istanbul? Or
Mumbai.
Mumbai. Okay. Okay. So while the proposal for buildings made from waste seems fascinating, how does one deal with the existing urban fabric facing scarcity of buildable space? Question from the group of Mumbai in India.
Okay. Well, as I showed on our proposals for Brooklyn, looking 100 years from now, it's kind of the idea to combine different functions, including mobility, within a single artery, where you can, densify by, going both below ground and above ground, and that will allow to open space for different forms of production. So I think in order to accommodate this future cities that are going to be built around the world, and this desire for people to live in cities, they'll have to be very dense. But that is smart density that lays the infrastructure in a certain way that can support life in every form. And as I said, if you start with the infrastructure and use the infrastructure of the organizing principle of the city, of the future, then you can allow for a hyperdensity as part of this movement of smart cities, where that idea that information is shared between different systems, and they're kind of self-controlling systems, and a modicum of intelligence is built into every system, allowing it to communicate.
Mm-hmm. Okay.
No, okay. Hello, I'm sorry, it was really good, and thank you for your lecture, but could you really a little just explain about the forces, different forces from city, and how you want to apply it into your project? Because I just found that most of your project was creating form using biology or investigation form from biological way in biological way. What about CD, and what about different forces from CD to the project?
And then I'm not sure what exactly do you mean by forces from the city. Do you mean political forces or natural forces? What kind of forces?
Example, strong force in the city.
Yes.
Okay.
Yeah.
I'm sorry, I didn't hear that.
No, I was making a reference back to the project, the 24-hour tower.
Yeah.
That I guess that would be considered quite a strong force that you are sort of utilizing to create design and to create different ways of habitating the city. So yeah, I guess his question was more geared towards these these tendencies, these kinds of ways to detect opportunities, such as this 24-hour tower and the amount of waste in cities, to more thinking about it as a driver, as a force to.
Yeah, I mean, obviously, you know, currently in New York, after Hurricane Sandy, a lot of thoughts and energy are going to, you know, designing with water and both protecting and then dealing with it. And I think with this enormous disbelief that, you know, what happened could happen. And now that it has, and it has shifted both the belief system, but also the kind of the willingness of all, you know, different levels of government and business owners to deal with it. So, you know, in our design, we've always tried to incorporate the fact that water, especially in a city like New York that is built on an estuary, is a factor that we need to address. With rising currents and increasing chances of these storms that we've experienced, 200-year storms in 2 years, so it's bound to happen again. Now this addresses both how you build the new infrastructure, the new building. We have to basically allow for the water to come in and come out. It's impossible what we saw to just keep the water away, I mean, without fortifying ourselves. So this is, you know, Mayor Bloomberg just announced new plans for stronger, more resilient New York, and then that will now ask all different designers to rethink how we build cities, and then, you know, including certain areas that maybe we should not build because they're in very high risk, but also, you know, how can, you know, be smart about it and accept the challenge and turn it into an opportunity. And with our project here at Media that I showed in the beginning, we're fortunate that, you know, when this wake-up call came with Hurricane Sandy, we're very early in the construction, so we were able to, you know, adapt. And it's kind of a key word that we changed the plans. We you know, now we're thinking about movable platforms that will allow us to elevate all the expensive equipment and also floodgates, but also saying, well, if we get flooded, this is a way to kind of bring water in, quickly drain it, and then make it part of the design process. And that wasn't ever part of the conversation before here in New York. And I think that it's a powerful force, and we also have this ability to now address it in a much more efficient manner, unfortunately following a major disaster. So if I can change one thing, it would have been we should have dealt with it because we knew about it for years. But nevertheless, it's in a way kind of this kind of higher level of activities from all the design community, and then there's we are running a competition here at Terreform One called for One Prize to address the question of storm-proofing cities. Take a look if you're interested. There all these agencies are getting together. Great kind of collaboration between local communities, the city of New York, professionals, design professionals. So in a way, it already is an opportunity.
Very good. Maria, maybe one more question here to just conclude everything. I think it's a good question for this. From Mumbai, they were wondering, what is the one factor in heavily urbanized cities, such as Mumbai and New York, that can trigger the future you have envisioned?
One factor. That's a very good question. It's a tough question. Well, my belief is that we need this a new breed of professionals that are equipped with with all these ideas and abilities to function and in multiple disciplines and in multiple scales, and then breaking all the silos of previously disparate occupations, and having this set of versatile skills and abilities to address the issues of future urbanization. So I think, educating and creating these new professionals, this will be the most important factors to assure the future of the urban world.
And with that, we'll thank you once again. Thank you so much, Maria.
Thank you. It was a pleasure.
And we look forward to connecting with you and the One Lab through the rest of the time we have here. So we'll set up some other. Okay, thank you so much.
Okay, thank you. Bye-bye.